All right. So I wanted to just do a really quick post today to kind of give an overview on a project I've been working on for a while. This is a project to make it really easy for using LEDs like the NeoPixels that everyone uses. Um, and to be able to make it, I wanted to make a board that you can basically just put into any project and give it some lighting and also some interaction without having to learn how to do any Arduino programming. This project came about because I've made a lot of LED projects for cosplayers and LARPers, as well as people who go out to clubs. And I've always published my code on my webpage or just shown them how you can go ahead and update. None of them are ever interested in actually doing that. Instead, they usually come back to me and say, hey, I want to change this to a different color, or I want to do a different pattern for the LEDs. So can you just rewrite the program and do that? So I got kind of tired of doing that because I'm all about education and trying to teach people how to do this stuff themselves. So what I've done is I've made a chip that is not intended to be reprogrammed. It is able to be reprogrammed, and essentially just by using a couple of buttons, you can cycle through different colors and different animation sequences, something that would make it very, very easy so that if someone wants to change the color, they can do it themselves without having to get into Arduino. Also give a little bit of feedback on it so that they can have, it can detect motion or something like that. So that was kind of the goal for this chip. I've been working on it for, I don't know, I'd say probably like about 6 months, maybe 9 months, something like that, off and on. So let me switch to my desktop so you can kind of see some of these things. So this is kind of like what started it all. What was kind of the inspiration for all this was Adafruit's Trinket. This was a really awesome chip. Originally, I had based a robotics platform off of this before they came out with the Pro Trinket, which ended up working out better. But I have a ton of these things, and I've used them in so many different projects. They're really, really cool, very cheap, and very reliable, especially just for running something as simple as NeoPixels. The only important factor of the board is going to be that little square on there. That is the ATtiny85 chip. It is a Arduino chip, a very small Arduino chip without a lot of pins, not a lot of memory, but it is really low power. So I do like it, but it has enough to where you can run a pretty robust program and at least control some NeoPixels for what I'm doing and for what most cosplayers and LARPers and even like anyone who's doing like LED wearables. This does more than enough for them. So I set out, and as much as I love these, I wanted to try and see what I can strip away from out of these and make it just as small as possible, and then also switch from these to kind of some dedicated pins, because I know what it is that I want to utilize out of it. I need to have a couple of buttons so I can select different modes. I need to have some sort of feedback for motion, and then I need to do some NeoPixels. So I don't need to have this mounted on a breadboard. So this is my one of my early designs. This was actually all done in EagleCAD, and I exported the toolpaths to my Shapeoko, and I actually machined these on my Shapeoko. I've made a few of these. They actually work really well. As you can see, now I have an ATtiny85. This is the larger breadboard mountable version, or through-hole version. Just it makes it a lot easier with these little sockets. I can actually, well, it's kind of difficult to pull them out, but I can actually pull the chip out which is important because I don't have a way of programming this. You'll notice there's no USB connector on that. So that's where this little guy comes in. So this is another piece that I machined. This is kind of like a half shield or a quarter shield for an Arduino Uno. This has all the traces on it and all the components so that I can actually program these ATtiny chips. They just seat right in there, and I load whatever program I need using the Arduino Uno as an ASP. And it works. It is kind of cumbersome though, because I have to pull, if I need to change the program, I have to pull the chip off of this board and then put it on this board, load the program, then pull this off and put it back on this board to test it out and see if it works. When I was going back and forth and doing the preliminary programming, that was rather difficult. But now I've gone into so this is actually a little bit more polished version. This is a set of 3 boards that I got from Osh Park. You can see it definitely looks a bit more professional rather than the other one. I've got some better connectors, and there wasn't really any change on this design from this design other than, so I've gotten rid of this extra connector for charging the battery. I had this idea that you could have a battery permanently on there, and then when it's off, it switches to a charging mode, which you connect via that. I did go ahead and abandon that and just have the JST connector for the battery on here. Since I can do double-sided very easily with Osh Park, the biggest change I made was I just made this a double-sided board rather than a single-sided board, which is what this is, because it's just much easier to do a single-sided board on the Shapeoko myself. But I have put this together, and I'm actually going to plug this in so I can show you kind of what the functionality is of this chip, because it is pretty cool. So it is turned on. So I have a switch here. I have a couple of different switches, and I've made the connection pretty generic so I can put different style switches. I do kind of like this plunger switch. This is a latching switch, which I figured would be good for wearables because you can kind of mash it down to turn it on and off. For this particular one, I have just a regular switch. So you can probably see those lights are kind of going on and off. Let me turn down my desk light a bit so hopefully you can see that a little better. There we go. So that's a little more noticeable. So you'll notice that there's a couple of things on this chip. One, there is a vibration sensor here. So this is, I believe it's a fast vibration sensor, so it's pretty sensitive. And you'll notice if I tap the board, the lights start blinking a little faster. So that's part of the program. Some of the patterns that I did have some feedback sequences in it. Some of them don't. So I'll cycle through a few of them. So this one right here lets you, let's see which one this is. So this one is, oh, I didn't label this one. Okay, so that one is the mode. Yeah, so I do see the labels on here. So this one, if I press and hold this, you'll see that the lights got kind of dim. Let me do that again. So they got kind of dim and they stay on. And then if I press the other one while I hold this down, it'll actually start cycling through the different colors. And then when I let it go, it latches to that color. So this is how you can change the colors. There's 9 different colors, I think, that I put on there, including white. The next one is the pattern. So if you press and hold this one down and then press the color button, it will actually cycle through the different modes. So this is taking a little while because right now I haven't figured out a way to tell the chip how many LEDs you have. So This is like a wipe sequence, so it's going to start at address 0 on the NeoPixels, and it's going to go all the way out. I think I set it to 90, which takes a long time. It does have a slight delay in it, so that's why it takes a while before it responds. But so some of these, I do have a plan to fix that though here pretty soon. So this is the color shift mode. If I go one more, this is kind of a cool mode. So this does kind of a slow pulse, but if I tap the feedback, it starts actually changing colors. It's very sensitive. I kind of have to work on that one a little bit more too, because it's, I think, sometimes a little too sensitive, but I mean, it's pretty cool if you're in a club jumping up and down. You can have it change colors. So that's pretty much what this does right now. So I have a dim setting, blink setting. Let's see. Yeah, so between them, I've got, I think, like 10 different modes now and 9 different colors. You know, obviously the color select doesn't work with the rainbow shift mode, but the or the motion detection mode where it changes color. And I probably have some modes like that, but for every other one, you can change the color as well as it doing some sort of thing on the chip. So all in all, I think it was something like 200 different options or something like that that I've been able to come up with for this board. So that is the current one. Now, what I want to show you is my my new revision A that I'm doing. So this is actually this is going to be the new chip. So this is what's going to kind of replace it. It is still in the beginning stages, so I just went ahead and made it square. I'll probably do one that's kind of like a square version for dropping into sculptures or something like that. And then I'll probably do another one that'll be a little rounder for wearable tech, but Osh Park charges by the inch, so I figured I would keep it as optimized as possible. This looks quite confusing a bit. I have changed a couple of components out. So I did add the charging breakout again because I have smaller JST connectors. Thanks to Phil at Adafruit for sharing the information as to where Adafruit gets those JST connectors, and I've ordered a whole bunch of different kinds that I found useful. So I'll be adding, so this is the typical one that is used on a lot of the Adafruit stuff. I like it. It's pretty cool. I've ordered a lot of them from Adafruit in the past. I just can't, I need to place bigger orders, and so I've started ordering them from DigiKey. And then also there's a couple of other form factors that I found that I really like for the same JST connector. So I ordered a different form factor for this one, which is the charging port. So this is another one that I'll be able to set up so I can still charge the battery without having to disconnect it from there. The switch is just going to be a generic 3-pole switch. So what happens is the battery comes into the center common pole. If the switch is over in this direction, it will power the chip and turn it on. If the pole is in this direction, it'll isolate the power from the chip and just make it available. So when you hook it up to a charger, it's just charging the battery. Also, if you have nothing hooked up to it, it just won't turn the device off. So it's kind of like a power on-off chip, but I figured with the two states, you might as well use them. This here is actually for a crystal, but I'm not going to be using a crystal on that. I'm going to be using the vibration sensor. It has pretty much the same footprint as the crystals that I've seen out there, so I figured it'd be a good one. This is, again, just a really easy way of being able to detect feedback from motion. In here I have a resistor, which is part of the connection that's detecting motion over here. You can see it's hooked up to, I believe that's pin 1 on the ATtiny. And then, of course, this track here, this is where the ATtiny 85 is going to sit. I have the breakouts for the color button and the mode button. Here are the pins for the NeoPixels, which I'll have these nice little brackets on. And then the newest addition is this track right here. So what this track right here does is this is a 6-pin connector, which is going to be able to hook up to this other device. So I did the program board, the program shield for the Arduino for programming the chip, but now I'm going to have this programming shield, and this will let me have a cable that I can just hook up to the board and flash the firmware onto the chip. This will make it much easier to test out a whole bunch of things because I won't have to unplug my chip from the board, plug it into this thing, and then flash it, then unplug it, plug it back into the board. I just have one cable, put it in there. I do have the staggering through holes so that I should be able to just use some of my header pins and it like not have to solder in, just kind of put that in there and it'll make contact. So that'll make things much easier. I'll have to see how that goes when I get the chip back in about 2 weeks. They've been pretty fast, so but hopefully it won't be too long. So if I go back here, so the reason I want to do this is so that I don't have to use that socket to plug the chip in. I can actually permanently solder an ATtiny 85 to this board so that it won't come off. The reason I really want to do that is because ultimately I'm going to be switching to a surface mount version of the ATtiny 85. That'll make things a lot easier, a little bit cheaper. I mean, not too much, but mostly I can just make all this stuff much, much smaller. And I think it increases a little bit of efficiency. Now, one word on efficiency, we tried this chip, my just original one, against a what was it, a Teensy, and or no, it was the Trinket, and just lit one LED with, I think, 150 milliamp hour lithium battery, fully charged. It was lighting one NeoPixel on pure white, and it lit that on the Adafruit Trinket for 1 hour, which is actually pretty good. For my chip, it actually lasted almost 2 hours. So I think a lot of that is just because the Trinket is really nice, but it's built for being able to prototype. It's built for being able to interface with the computer. So there's a lot of extra stuff on there that you don't necessarily need, and I think it probably just over time adds up. Not to mention that there are a couple of LEDs on the board itself to indicate power and even data transmission. So really, you're not just running one LED, you're running like one, or you're running 2, if not 3 LEDs. So that's definitely gonna affect battery life to a certain extent. So yeah, this definitely it's working out pretty good so far. I've got a lot of people that I've been using this chip in projects for. Hopefully I'll get a lot more, and when I get this, I'm going to go ahead and just film me putting it together. I'm really excited about this. I've also been designing, taking the design for the lithium-ion charging circuit that Adafruit uses, and I'm actually designing my own charging board, and I'm going to be trying it out. If it works, I'm actually going to try and integrate it into all of this. So I haven't decided if I'll have to look at how much it costs. I may just have it as a built-in integrated thing, so I can get rid of this and just have a USB connector. So you plug in your battery here, you'll have a USB connector that you just use to charge the lithium battery, because I'd rather not have people pulling the battery in and out. I know it wears down on the wires quite a bit. So we'll see how that goes. Although I may just have a version like this that I might develop and sell eventually, and then have another version, like an upgraded version with built-in charging on it for a little bit extra. So we'll see how that goes. Ultimately, I'll be producing these in low volume runs, probably through Osh Park, and just hand soldering them for a while. But there are a couple places here in Seattle that are part of the Seattle Made organization, which we're a part of here at Soto Makerspace as well. And I'm going to probably talk to them if people want to do this, and see about actually manufacturing these on a larger scale. So that's pretty much where I'm at for right now. That's the project. Like I said, sometimes I get a lot of time to work on this, sometimes I don't. But that's pretty much what this is all about. Hoping to get this a little bit further along here pretty soon. So that's it for now, and I'm gonna probably head home because it's getting a little late. But thanks for watching, and we'll see you next time.